In the previous video, we learned about units, the language we use to measure physical quantities. Today, we go one step deeper. Today's topic is dimensions. What do you mean by dimensions? In physics, the dimension of a physical quantity tells us what that quantity is made of. It tells us how a quantity depends on some very basic physical ideas. In mechanics, almost every physical quantity can be expressed using just three basic dimensions: m for mass, l for length, and t for time. These are called fundamental dimensions. Using combination of m, l, and t, we can describe most physical quantities in basic physics. Why are dimensions important? Dimensions help us look inside a physical quantity. They help us to understand how one quantity depends on others, compare different physical quantities, and check whether a physical equation makes sense. This method is called dimensional analysis. Let's look at some simple examples. First example is velocity. What is velocity? Velocity is displacement divided by time. So its dimension is Lt minus 1. Let's take acceleration as a second example. Acceleration is velocity divided by time, and dimension of velocity is Lt minus 1, so its dimension becomes Lt minus 2. In this way, many physical quantities can be expressed using combinations of m, l, and t. Can you find the dimension of force? Yes, it's so simple. From Newton's second law, force equals mass multiplied by acceleration. Mass has the dimension m, acceleration has the dimension Lt minus 2. So the dimensional formula for force is mLt minus 2. Now comes one of the most important ideas in physics, the principle of homogeneity of dimensions. This is very important. It states that in any correct physical equation, all terms must have the same dimensions. This means you cannot add or equate quantities that have different dimensions. For example, you cannot add force and acceleration, but you can add quantities if their dimensions are the same. This principle allows us to check equations even without knowing their full derivation. Let's apply this idea to a familiar equation, s equal to ut plus half at square. Here s is displacement, u is initial velocity, a is acceleration, and t is time. Now let's check the dimensions. You know the dimension of displacement is L, dimension of ut is Lt minus 1 times t, and which is also equal L, and dimension of half at square is dimension of half times dimension of a times dimension of t square. Since half is a constant, so its dimension is 0. There is no dimension of a constant. So dimension of half at square equal to Lt minus 2 times t square, and which is equal to L. All terms have the same dimension here, that is L. So this equation is dimensionally correct. So what we learned in this topic is the dimensions are not just symbols, they are a way of thinking in physics. They help us understand the relationship, check equations, and avoid mistakes. In the next video, we will use dimensional analysis to derive formulas and solve real physics problems. Until then, keep questioning, keep exploring, and keep enjoying physics. Thank you and see you in the next video on evigyan.